Hello, everyone. This is going to be Tuesday lecture. Uh, I think, well, the Monday lecture was the introduction video. So I hope everyone has already watched that one. Um, okay, on this one, from this video, which is Tuesday lecture, from this one, I will be starting the actual mathematical lecture. All right, so before I start, uh, uh, probably you guys have noticed my introduction video that you guys need to submit your quiz. And I said that the quiz is going to be within the lecture, right? So I have explained there, so I won't explain it one more time. So, uh, so you need to watch the whole videos. Let's say this 1.2, you have to watch this whole video to see if I assign anything throughout the lecture. So you have to watch the whole lecture to see that. All right. And in case if I assign anything, you need to go to the Blackboard. So if you go to the Blackboard, let's go to our course. And then I've explained this in that introduction video as well, but yeah. So once you go here, you will see this, the quiz assignment lecture, this tab, right? So you just have to click there. And all right, so so this one is for the first week, right? So if you go to the first week, if you click there, I have created a tab. So you just have to click here, and you will see, yeah, you just have to upload your work from here and just submit it from there. All right, so um, so basically I'll create a tab for each section. All right, so each section I'll create a tab, and if I assign it, just submit your work on that tab or that section tab. But in case if I do not assign anything for any lecture, then you don't have to submit anything. You don't have to, all right? You have to submit only if I assign the quiz. Okay, just be clear on that. And if you're still confused, just you can still ask me during the office hour or just email me. All right, so again, on this lecture, make sure you watch the whole video to see if I assign anything. All right, so if I don't assign anything, you don't have to submit anything. All right, so that's the first thing I want to talk. Now let's start. So in this section, basically just the review of algebra. So I'll just quickly go over the few things that you learn in the algebra. All right, so I'm not really gonna go deep into it, expecting that you guys know it. All right, so since you're taking the calculus one, so I hope most of you, or maybe all of you guys took at least college algebra, right? Or maybe pre-calculus, or maybe trigonometry or stuff like that, those classes. So I hope you guys know those basic things, but still I want to just cover a few things in this section. All right, so let's start first from linear function. So the linear function means basically it's a straight line function, right? The linear said that, right? The straight line. So let's say, okay, so the linear function, the equation of the linear function is y is equals to mx plus this, mx plus b, sorry. So this simple equation, right? And where m is the slope, and b means y-intercept, right? So let's say if we have 2 points, and if we make a line that goes through these 2 points, all right, and if I name this point x, y, and also this x, y, and just to make these 2 points different, because these are 2 different points, let's say this x1, y1, x2, y2, then I can find the equation of this line using this formula, right? So I hope you guys learned this thing in college algebra. And the way we find, first we need to find the slope. So the way we find the slope of this line is, well, using these 2 points, I can say slope, or m is equals to y2 minus y1 over x2 minus x1. Right? So yeah, simple idea. The next one is polynomial function. Okay, so the basic form of the polynomial function is, let's say polynomial, let's represent polynomial as p of x is equals to a x to the power n, where a is a constant, some constant number, all right, and n on the power, the n is non-negative, so n and the power cannot be a negative number, non-negative, or basically you can say a positive number, or yeah, non-negative. So and also n is integer, so that means n cannot be a decimal number or a fraction, right? So yeah, you need to satisfy this condition, and also the equation or the function should be in this form to say that it is a polynomial function. All right, clear? So if I say 2 times x to the power 3, then this is a polynomial function, right? Because this n on the power is non-negative, and this is also integer, right? Because 3 is integer. All right, and also we can also say a polynomial if we have addition or subtraction of a function of this form. So let's say 2x to the power 4 plus 7x to the power 3 minus 5x to the power 2, I don't know, let's say plus 2, something like this. This is also a polynomial function, right? P of x is equals to this. Let's say P of x is equals to this. All right, so we can even say this kind of function is a polynomial function. But can we say that? Can we say 2 times square root of x plus 3x squared plus 7, something like this? Can we say this is a polynomial? No, right? Because now we have a square root of x, and using this concept that n should be a non-negative number and it should be an integer. But here, if I change this to, well, square root of x, I can also say x to the power 1 over 2, right? So that means on the power we got a fraction, so 1 over 2 is not an integer, right? So that's why this is not a polynomial. This is a polynomial, this is a polynomial, right? Okay, so yeah, basic idea, right? Okay, so another one, quadratic function. So quadratic function is also a polynomial function. Quadratic function is a type of polynomial function. All right, so quadratic function, basically quadratic function, we can write quadratic function in this form, right? Ax squared plus bx plus c, right? And let's say this is f of x. Let's just name this function as f of x. So whenever you see this form ax squared plus bx plus c, that means it is a quadratic function, right? And the graph of a quadratic function is basically going to depend on the value of, or yeah, the value of a, or basically if a is a positive number greater than 0, then the shape, we are not looking at exact graph, just the shape of the graph. The shape of the graph is going to look like this, or we can even say this is concave up, right? And if this a is negative or less than 0, then it's going to be something like this, concave down. Right? And also to solve a quadratic function, this form, so let's say if we have something like this, and this is equals to 0, right? To solve something like this, now we can also use a quadratic formula, right? So quadratic formula is, let's say if you're trying to solve means, we're trying to solve this means we are trying to find the value of x. So x is equals to negative b plus minus square root of b squared minus 4ac over 2a, right? Okay, now another one is a rational function. I think you have also learned about this. The reason I'm going quickly over this thing is basically in this class we are not really looking at the algebra stuff, right? Because this is a calculus class, so we will be focusing more on calculus thing, right? So that's why I'm assuming that you guys know this thing, but still I just wanted to go quickly over these things just to remind you whatever you learned in college algebra, right? Um, so yeah, rational functions. So the rational functions is basically the division of two polynomials, all right? So the rational function is the division of two polynomials. So px over, let's say, q of x. Okay, so both of these are polynomial. It's a big polynomial, and uh, anything on the denominator should be, well, it cannot be 0, right? Because anything, anything divided by 0 is always undefined, right? So that's why we have to make this conditions that the thing in the denominator is not equals to 0. Okay, so this kind of function, we say this is a rational function. Okay, now I want to talk about the domain. The domain. So the domain means all possible values of x, right? If a function is given, let's say if a function is given, so something like this is given, x plus 3 over x minus 4. So, well, we can say this is a rational function, right? Because this one on the top, x plus 3, is a polynomial. This one on the bottom is also a polynomial, right? Because x plus 3, well, even though it is a linear function, well, linear function is also a type of a polynomial function, right? Anyway, so now we need to find the domain of this function. So how do we find the domain of this function, or how do we find all the x values that are possible for this functions? So to find this, basically, whenever you see an equation with a fraction, we can directly look the denominator part, right? Because here we said that the denominator cannot be 0, right? So we have to use the same conditions here. So now if I say, okay, x minus what that is in the bottom is equals to 0, then the x value we will get here is 4. So that means if I say x is equals to 4 here in this equation, we will get denominator 0, right? Because if I say x is equals to 4, then we will get x plus, or sorry, x is 4. So 4 plus 3 divided by 4 minus 4, right? Which will give 7 over 0. So this is undefined, right? That's why x cannot be 4. So the way we write this, using the interval notation, there is this thing called interval notation, is everything is possible except 4. So if we are not, that means we cannot include 4. So if we are not including 4, then that means we are going to have an open circle. Well, this is, we call this a number line. So we cannot say x is 4, right? We just said that. We just proved here why we cannot say x is 4, right? So everything except 4 is our domain, right? So now to write this, everything else is possible, right? So from negative infinity to positive infinity. So now to write this, well, there are different ways. Let's write this in interval notation. Interval. All right, so interval notation, it's going to go from negative infinity to 4, right? So from negative infinity to 4. And okay, so on this side, if you're not including, well, basically here, infinity side, well, infinity doesn't have any stopping point. All right, so that means we don't know where to stop. So if that means we don't know exactly the infinity point. So in that case, we're just going to say circular bracket or parenthesis. All right, so if we are not including anything, that means we're going to have a parenthesis. And if we are including, then we are going to have a bracket or a square bracket. All right, so again, 4 we are not including, so that's why we have a parenthesis, u 4 to infinity, right? Anyway, so yeah, this is basic idea of finding domains, right? What about, let's say, if we have a function with a root? So in this one, with the root, so if I say the square root of a negative number, well, we won't get a real number from this, right? We will get an imaginary number. So where we have to deal with I. So that part we are not really going to look at for this one to find domain, all right? So square root of -1 is not possible because we won't get any real number. So we're just going to say it's not possible. And square root of 0 is possible. Square root of 0 is still 0. So that means everything that is inside this square root must be, so everything that is inside the root must be greater than 0 or greater than equals to 0, because we can also include 0, right? Because it has to be positive. So from here, we can say x is greater than equals to 5, right? So if I see this in number line, let's say 5 is here, and in this case, we have x is greater than equals to, so if we are, now in this case, we're including 5, so if we are including 5, then we're going to have a closed circle, and x is greater than equals to 7, means everything on the right. So it'll be our domain, right? So on the right, it's going to go to infinity. So now to write this in interval notation, our domain is going to be from 5 to infinity. But in this case, we are including 5, right? So if you're including 5, then that means we're going to have a square bracket. And on this side, we don't know exact stopping point of infinity, so circular bracket. And let's say if we're finding the domain of just a regular polynomial, all right? So it's just x to the 3 times x to the power 4 plus 5 times x to the power 2 plus 7. All right, so if you're trying to find the domain of this regular function, a regular polynomial function, then since we are trying to find the domain, so so the domain means all the possible value of x, right? So if I take any x here, it will work, right? Any x, it doesn't matter, negative billion or positive billion, it's still going to work. You will still get some number. So that means it's all real number, right? So the way we write this is from negative infinity to positive infinity. And on both sides, we have parentheses because, like I said, we don't know exact stopping point of the infinity. So that's what we have, a parenthesis on both sides. All right, clear? Okay, so now let's go to the next topic. Exponential function. So the exponential function are a y is equals to, let's say, a to the power x. So this a on the bottom is some constant, right? And it has some conditions. So the a on the bottom should be greater than 0. It should be a positive number. And also this a cannot be 1. Okay, so if we have this condition, and if you have this form, then we say this kind of equation is an exponential function. Okay, so that means y is equals to 2 to the power x. Well, this is an exponential function, right? This satisfies this 2 on the bottom, on the base, satisfy this condition, right? Y is equals to, so this is an exponential function. So y is equals to 1 to the power x. Well, like I said, on the base, it cannot be 1. So this is not an exponential function. Y is equal to negative 2 to the power x. Again, on the base, we have a negative number, but we said here that a should be a positive number, right? So that's why this is also not an exponential function. Okay, so now let's look at the graph of an exponential function, how the graph is going to look like. So basically, the graph of an exponential function is always going to be like this. All right, it's exponentially growing from left to right. This is x, if this is y, right? Because it's exponentially growing, so that's why we call this exponential function. And this is always, the shape is always like this, all right, the shape. And it always goes through 0, 1. All right, so even though you said y is equals to, for 2 to the power x, the shape of the graph is still like this. Maybe this one is, well, this growing thing could look different, all right? But overall, the shape of the graph will look something like this, all right? It doesn't matter even if you say y is equals to, let's say, 1 billion to the power x. Still, the shape looks something like this, all right? And this shape is something like this if a is greater than 1. All right, so we said a is going to be this condition, so a must be greater than 1 to have a shape like this. And we're going to have this exponential decreasing, or we can also say exponentially decay. All right, so still this is going to go through 0, 1, and the graph of this, well, something like this is if a is in between 0 to 1. Okay, so still this a satisfied this condition, right? And also this a satisfied this condition, but it's just that it's going to be decreasing if a is in between 0 to 1, right? We said that a can be anything greater than 0, but it's just that it cannot be 1, right? So if it is in between 0 to 1, it's just going to decrease. If it is greater than 1, it's going to increase. The shape is always going to look something like this, all right? Okay, now let's look at the last one, logarithmic function. Well, everything I talked so far, I'm just going briefly over this. So later on, when I go to the next chapter, or later on when I go to a different topic, if I need to review, or if I need to go in detail on this topic, I will probably do that later on. But it's just that for right now, I'm just going to go briefly on this. It's just that I expect that you guys know it from calculus, but still I want to go over this thing really quickly, just to review that you guys did before. Okay, anyway, the logarithm function is y is equals to log base b of x, right? And this b is a constant with this conditions where b should be again greater than 0 and b cannot be 1. The conditions are pretty same to the condition of exponential function. Okay, and the graph doesn't look perfect. Well, better, yeah. Okay, now the shape of a log function or logarithmic function now is like this, which goes through. Well, this point is going to be 0, 1. Sorry, it's going to be 1, 0. This is x-axis, so it's going to be 1, 0, right? And the shape is so this one is never going to touch y-axis, and from here it's increasing, and this one is the shape is like this when this b is greater than 1. All right, another one, again, this is not touching, this is just approaching towards y, but it's never going to touch y, and the shape is like this, and here b is in between 0 and 1. All right, so yeah, I briefly went over a few things that you guys learned in algebra. So yeah, if you watch the whole videos, probably you figure out whether I assign anything for quiz or not. All right, so anyway, I'll see you guys in the next video, and hopefully I'll see you guys in the office hour as well, just in case if you have any questions. And make sure you guys do the homework, the wave assign homework as well. I'm going to do the separate announcement about that through email or through the announcement in the Blackboard. So check your email and announcement frequently to see that, and also you can probably see that from the web assign as well. If you just go to the web assign, probably you see the details of the due date as well. All right. All right. Yeah. And one more thing. Oh, I think I forgot to tell you about the due date of the quiz. All right. So the due date of the quiz is basically, let's say, so this 1.2 is Tuesday lecture, right? This 1.2 is the Tuesday lecture. So if you watch this whole video, then probably you will figure out whether I assign anything or not. But if I've assigned anything in this lecture, then the due of this quiz, is going to be the next day. So since this is Tuesday lecture, right? So the due of this one is going to be the next day, Wednesday, midnight. So the due of the quiz are always going to be the next day, midnight. All right, so the due will be next day, midnight, 5:59 p.m. Okay, and the next video will be 1.3, right? So that means the 1.3 quiz will be, so that will be, next video will be Thursday, because we don't have any class on Wednesday, right? So Thursday quiz will be due next day, Friday midnight. So it will be always due on the next day. So the quiz will be, yeah, like I said, the quiz will be always due next day, midnight. All right, just be clear on that. All right, anyway, thank you.